have built this prototype to test one thing. Can I play tight music with marbles? If it turns out that I can play tight music with marbles, I will build a new full-size marble machine. But if it turns out that I can't play tight music, I will actually put the whole marble machine project to rest. In this video, I'm going to begin testing, and the results of these tests will determine my and the Wintergatan YouTube channel's future. But what is actually tight music? To get a benchmark, I recorded myself playing with these drumsticks, and I'm not a drummer, so a drummer could do this better, but let's see how tight a human can play. Here's the results from Titanator.fun, and we can see that I actually started and ended at the same exact tempo, and I had a total standard deviation of 44 milliseconds. So now I took some headphones on and I tried to play to a click to see if I can play tighter with a click. With the click, I am tighter, 15 millisecond standard deviation. A real drummer would get a much better result than I did here, but it's great to have a human benchmark so that we can compare the prototype results to me playing. And while getting benchmarks, let's actually check out how tight the Marble Machine X was. So let's analyze this audio. The Marble Machine X is driven by an electric motor here, so the tempo should be pretty good. And we can see that it has a deviation of 5.3 milliseconds, so it looks like it's playing 3 times better than me. But to compare the tightness of different tempos, we should actually look at the deviation in a percentage level. And here the MMX is actually playing almost 5 times less tight than I am. So it's not really an apples to apples comparison. A simple way to put it would be that the more often you play, the less chance you have to make a big mistake, kind of. But we don't have to go into that right now. We have our benchmark, and just as a fun note, you all think the Marble Machine X played so tight because I made it sound awesome in the videos. Check out this intro where I added a lot of music around the Marble Machine to make it sound like it could play really, really super tight. But this was actually mostly achieved through post-production and tricks in my music software. I think it was produced music montages like this that made everyone think the Marble Machine X could play much better than it actually could. In real life, it actually sucked, which is why I choose to cancel the project. But anyway, now we can see if this prototype can play tighter than me and the Marble Machine X. That's the whole goal for today. Before starting the testing, I wanted to show you how I got all this together. I needed to decide on a gear ratio between the flywheel and the programming wheel, and I used this timer to time a good pace, and I ended up with 3.5 seconds, which would be 8 teeth. I wanted 4, 8 or 16 teeth for music tightness reasons. So here's the double helical gear, and I made these little points so they can snap into each other nice like that. I printed the gears and it looked really, really nice, but when I tried to mesh it with the programming wheel, it didn't mesh at all. And I was like, what's the problem here? Then I checked my settings and I forgot to put Sunderland. You can see how the gear is shrinking here when I go back to the Sunderland system. So that was my mistakes. I printed new ones and they meshed perfectly. I had to redo the gear train to this, so with a new axle I could then put the new gear on, and then we have to find a correct depthing. So the depthing is the distance between the two middle pivots between the gears. So you can see I'm rocking it back and forth, and the further away we have the pivots, the more backlash we have. And the closer, the less. And there's advantages for both, but I'm using these oversized holes and a screw with a washer. And when I find the perfect spot, I can tighten the screw and the system is ready to go. Now I want to connect the programming wheel to the marble droppers. And just a reminder, this is the prototype with the muting lever, so nothing happens here. And I put it on, and now the marble is being dropped. So I'm taking all the parts of the plywood here and I'm putting it on to the programming wheel. I'm using a contact microphone from Ireland that are designed to use the tacket. And here we have our first floor marble for 2023, everyone. I know you've been missing those. And in the words of Ivan Miranda, they will give me the strongest back on YouTube. So welcome back, floor marbles. And just when I was starting to be ready for test one, the whole thing broke apart and I had to take everything apart. The issue was this little crack in the ratchet. So I actually built a new improvised ratchet stronger from plywood instead of a 3D print. So this is how it works. You can see that I can spin one direction but not in the other direction. And then I printed a new 3D printed ratchet as well, so this axle have ratchets on both sides now. Okay, now everything is ready. So this is how it works. We have the flywheel, and on the flywheel we have this little test thing, plastic strip. The plastic strip is hitting this contact microphone. And the contact microphone is being recorded into my music studio on a separate channel in my computer. So the flywheel timing channel is recording the flywheel separately. And this crank I took from an IKEA desk is lifting the 30 kilo heavy metal-filled suitcase. The weight of the suitcase is weighing down this gear here, and the gear goes into the flywheel, and through the flywheel axis we have the gear to the programming wheel, and the programming wheel profiles are hitting the reader, and right now it's muted, so we have to unmute it with this lever here, and next time here a marble will be dropped. So now we have a full channel prototype of a marble machine, which is something that I've been dreaming about building for 2 years. And I can already tell you that this prototype is amazing. I'm learning so much from working with it. And instead of just starting to build like I did on the previous machines, I can actually test what works and what doesn't, and I can fail cheaply. So it's really, really nice process. So the marbles are being dropped on this plywood plate with the contact microphone. And that contact microphone goes into the second track in my music software. So this way we can record a flywheel and the marbles separately. And last, I have a speaker on my desktop outputting the sound from the flywheel, and in front of that I have a BPM analyzer. You can actually see the speaker here moving here, which is pretty cool. And this way I can get a real-time readout of what BPM we are playing in. Test one. I'm not gonna bore you with all the details, but we can do so much with the data from these two audio channels. In my spreadsheet here, I can calculate a lot of different things and look at this in different ways. But to just summarize, I think there are 3 values that we should really check. The marble drop deviation of test 1 was 0.85 milliseconds, and this is how much difference it was between the marble and the flywheel. This number doesn't care at all about which BPM we are playing in and if the BPM changes. It only measures the consistency of the marble transients compared to the flywheel transients. The next number we should look at is tempo deviation. This is how much the flywheel is changing tempo. Test 1 had 1.6% tempo deviation. And then we have the music deviation, which is the whole system as a whole. So now we're measuring the flywheel and marble, and this is what a listener to a song would hear. And in test 1, this was actually pretty bad, 17 milliseconds. I felt there was a lot of friction coming from the reader. So I'm not going to be too worried about this first result. Instead, I went and moved the reader away so there was less friction, and I started test 2. Test 2 had much better result. We have a better marble drop deviation. We have only 0.4% tempo deviation. And we have a great music deviation, 2.79 milliseconds. So at least twice as tight as the Marble Machine X and a lot tighter than what I played. Of course, for test 3, I need a metal band to play really tight music. As we've seen before, more moment of inertia equals tighter music, so I'm adding more weight on the outside of the flywheel with these metal bands. And this was actually exactly what I did on the original Marble Machine, so this is a throwback to a hack from several years ago. And the tempo deviation was better, but the music deviation was worse, and I don't know really what happened there. But I felt that the tempo of this test was a little bit too low, so I'm adding a bag of marbles to the weight to get a higher tempo, and it started to play really fast, like 150 BPM. But the results were actually worse again, and I don't know exactly why. For test 5, I printed these longer hold time profiles. And the result was actually better. We had a music deviation of 3 milliseconds, which is better than the Marble Machine X and better than me, and almost as good as the best test we had so far. And for the next test, I wanted to drop more marbles, so I put all 4 programming profiles on the programming wheel at the same time, and lifting the marbles here got really hectic because this is pretty fast. Since we're playing much more often, I'm expecting a better result. And yes, we had 2 milliseconds music deviation in this test and really good tempo deviation of only 0.22%. So we are getting in the right direction. But here I actually ran out of time. But if we take a step back and just listen to the marbles playing here, I think we can agree that it sounds very, very good actually. I'm not ready today to make any decisions about the future of the marble machine. I have to continue these tests, but I can tell you that the process I'm doing now with benchtop prototyping like this, where I can fail fast and fail cheap, is so much better than what I did on my earlier machines. On my earlier machines, I did no prototyping. I just started to build them and they both failed. And I'm still feeling the pain from both of those failures. I really do want to revenge myself if I'm ever going up in the ring against the marble machine for a third rematch. So yeah, no conclusive results here, but I've learned a ton this week, and this is probably going to be a little bit of a series here now, where every week I will go deeper and deeper into this testing and see how far I can optimize this prototype and what I can learn from that process. Thank you so much for watching, and good luck with everything you're doing. See you next week.